You might not think that helping a stroke patient learn to walk again has much in common with discovering the next-generation materials for our smartphones, but it turns out they do. The connection is an innovator named Min-Soo Chang, a roboticist who's built his career creating that exact bridge between human needs and automated solutions. Let's dive into his incredible journey.
This quote, "This is everything." It's the key to understanding his entire philosophy. See, for Min-Soo Chang, it's not about replacing people. It's about building robotic partners that can learn, adapt, and amplify our own expertise. That's the vision that's really driven every project he's touched. So we're going to follow his career path, which is really a tale of two very different but super high-impact fields. And you'll see how this core set of skills in robotics and AI can be used to solve problems that seem worlds apart, but are both incredibly important.
Okay, let's start at the beginning, in the world of medical robotics. This is where Min-Soo took on his first massive challenge during his PhD, completely rethinking how patients recover from really serious mobility issues, like the kind you see after a stroke.
So this was the central question he had to tackle. Because, a lot of the therapy robots back then they were pretty rigid. They just followed these one-size-fits-all programs. And that's the total opposite of how a human physical therapist works, right? A good therapist adapts to you in real time.
And this slide just lays out the difference perfectly. On the one hand, you have the old way, a clunky, pre-programmed machine that basically needs a human babysitter. But on the right, that's Min-Soo's vision, a smart, adaptive partner that actually learns from the patient and tailors the therapy, session by session, moment by moment.
Of course, before you can personalize anything, you have to nail down safety. That's job number one. A patient is never going to recover if they're afraid of falling. So this innovation was all about creating an exoskeleton that could literally think ahead, stabilizing the person before a fall even has a chance to happen.
So how'd he do it? Well, this breaks down his patented method, and it's actually pretty elegant. The robot is constantly watching the person's posture. It's scanning the ground to see if it's flat or sloped, it calculates the risk, and then it acts instantly to keep them stable. It's basically a life-saving algorithm broken down into 4 simple steps. Now, here's where it gets really cool. This wasn't just some theory stuck in a university lab. Min-Soo's work got put to the test in the real world, where it could actually change patients' lives. 6. That's the number of major hospitals across South Korea that took his innovative gait training systems and put them into clinical trials. We're not talking about a small-scale test here. This was a serious effort to see if the tech worked in actual clinical settings. 90. That's how many stroke patients took part in these trials. This provided just a treasure trove of data, real human data, that was absolutely crucial for validating the technology and refining the AI to make the robots even smarter. And that led to this number, over 1,200. More than 1,200 robot-assisted training sessions were conducted. That is robust, large-scale validation. It showed, without a doubt, that his work was having a real impact on patient recovery. And the heart of all this success was a concept he called the AI therapist. This was the brain behind the robotic brawn. It's what made the machine smart enough to actually mimic the complex decision-making of a human expert. This was a huge leap toward truly intelligent, scalable rehabilitation. Okay, so after all that success in healthcare, you might think he'd just stay there, right? But Min-Soo made a really interesting pivot in his career. He shifted from helping patients get back on their feet to helping scientists make world-changing discoveries. You can see the strategic move right here on the timeline. He took all that deep expertise he had honed in the super demanding world of healthcare and pointed it at a totally new frontier, industrial automation, specifically at the Samsung Advanced Institute of Technology.
And you don't have to guess why he did it. Min-Soo explained it himself. This wasn't just about a new job. It was about expanding his mission. He realized that the same core principles of smart, adaptive automation could be used to speed up innovation on a massive global scale. So at Samsung, he walks into a whole new world with a completely different kind of problem. Now it's all about accelerating the discovery of new materials, a process that is often painstakingly slow, sometimes dangerous, and always demands incredible precision.
The big challenge here is that creating new materials, the kind that power our future tech, often involves complex chemical synthesis. And that can be hazardous for humans, it requires a level of precision that's hard to maintain, and frankly, it's just slow. It's a major bottleneck for scientific progress.
His solution was brilliant. Build a robotic chemist. Imagine a system that can handle hazardous materials with perfect precision, navigate a lab all on its own, and work around the clock, 24/7. This frees up the brilliant human scientists to do what they do best: think, analyze, and discover.
And the impact was, well, immediate. His work on safe robot navigation was accepted at ICRA, which, if you're in the robotics world, you know is one of the absolute top conferences on the planet. That's a huge deal. He's also racked up multiple US patents, which just proves the novelty and the real industrial value of the solutions he's building.
So, we've gone from a hospital rehab wing to a high-tech Samsung lab. What's the common thread? What ties this whole incredible journey together?
It all comes down to this core expertise. This is his toolkit. Whether the robot is interacting with a patient's leg or a tiny vial of chemicals, the fundamental skills are exactly the same. It's about designing complex systems, writing brilliant control algorithms, and using data to make machines smarter.
When you look at Min-Soo Chang's career, it's just such a powerful story of how one person's deep expertise can ripple out and transform entire industries. It challenges all of us to think bigger about that amazing potential we unlock when we bridge human ingenuity with robotic precision. And it leaves you wondering, what other huge challenges are out there just waiting for a solution like this?